Alright, OBS says I'm live. Let's go to YouTube and see when that says I'm live, and we should could be good. I don't see an image, but that can be streamed that can be YouTube sometimes. So there we go, image up. Okay. So today's plan is to add like a power grid to Untitled Dinosaur Tycoon game. I'm not entirely sure how I'm going to go about doing this. What I realized while I was trying to set this up for a thumbnail is, first off, terrible, but I need to add like a modification to the Bevy's PBR shader so that I can specifically specify different like so you can see the vertexes, because at the moment you can't actually see that there's a corner here. Like there's no way to tell that these are actually, there's a slope and a flat. It just looks like an edge, and it's only that there's two different colors, which makes it impossible, which I learned when I made this power pole the same color as everything else. That's why it's actually a different color, is that you couldn't see it because it perfectly blends in because it's not actually using normals at the moment. So I've done this before, everything's broken on YouTube apparently, where I've, why is the chat broken? I bet you it's because I'm not actually signed into my correct account. It's weird that YouTube lets you do that. So yeah, I've done it before, where basically you can recalculate the normals to be the tangent of the face, which makes them work without needing to specify individual vertexes, because the way that I believe Bevy works with its normals is I would have to, if we go over to Blender where you can see, hide everything and unhide like this. So at the moment in Blender, these all have their vertexes shared. Like they're actually shared vertexes. When I export them, the different colors get split into materials, which means that this vertex gets stubbled because it's both brown and yellow. But there is actually a normal, if I turn on this corner, and as you see, these ones are pointing out that way. And I don't want that because that causes the corner to sort of blend across. What I actually want is these two to use a normal pointing up, so that I get normals like these arrows, these blue ones, and that's just the tangent normal. It means that the normal is pointing directly out of the surface, and you have to do that with a custom shader, because I don't think Bevy lets you just select that as a thing. And if I don't do that, then it means you can't actually see, like in Blender, you can actually see that this is a corner, whereas in my game you can't, wherever the corners have gone. You can actually see that there's a corner there. And it looks much nicer for this kind of low poly art to have sharp corners and like different faces rendered as different tangent angles. So the tricky thing is remembering how to do that. So first thing we're going to do is we're going to go into our assets and add a shader, because that's what you got to do. So assets, new folder, shaders. I'm going to try and track down Bevy's PBR shader. So I guess we go main, no, lib, load shaders. We create a bunch of shaders like so. Why are you telling me that to spell wrong? That's because that is definitely spelled wrong. Like that. Yes, please. Okay, somewhere is now a folder called shaders. And this is where we go use Bevy preload. Alright. So the first thing we're going to try and do is track down Bevy's standard material. So we'll just make a test function, just so we can go standard materials. So if I go into standard material, and we go in here and go shader, somewhere, we have lots and lots of stuff. I don't know how to tie into the pipeline. And this is where it gets really confusing. Okay, there, fragment shader. I'm going to have to do a bit of Googling here, because I need to track down shader pipeline. So another great thing for watching if you're going to like work out how to look up things in Bevy. So this is the spec. So, custom rendered mesh pipeline plugin. So this is a mesh with custom attributes. Okay. Custom plugin. Yeah, okay. So this is a rendering app in it. Specialized material mesh pipeline custom. But how do I get into the pipeline? I want to like add to the pipeline. There's a way you can like render the pipeline. I've got the editor. Does the editor have renderer? Okay, that's big. Features. It's definitely a way. Because what I could do is I could just copy paste the standard material, like all of this code in here, and just copy paste that, and we go wherever the shader handle is. PBR shader. Somewhere it loads the shader. Like I could just do that, but I want to like, there's definitely a way to like get into Bevy's pipeline and like tell it to render, or like to run your shader before it runs the next shader, like pass the output of your shader into the next one. And all they need to do is grab the normal, recalculate the normal, and pass the normal over. Like it doesn't require much. So Q custom mesh pipeline. Pipeline cache, custom mesh. Okay, so let's see if we can try Bevy add shader to pipeline. See if that comes up with something. Custom phase. Okay, so we're rendering a triangle in this thing. Again, it's not quite what we want, because these I feel like are just custom shaders. If we go to assets and go, there's an outline. See, this obviously ties into the pipeline rather than overriding anything, because it will still render correctly. So I reckon we go into here, we go, there's a lot going on. What do you do? Labels for render graph nodes. Okay. And stencil enabled offset. Okay, yep. Yeah, plugin. Okay. So load internal assets. This loads the shader. Okay. Extract component plugins. Register some required components. Add systems post update. Sub app. Okay. Draw functions. I'm looking for where it's editing the pipeline. It's gonna just be easier, isn't it? God damn it. I don't like when this is the case. It's just easy just to copy paste the code because I don't know where. Add render graph edge. Add render graph node. Okay. So does this mean that it's like it's added between these 2 points? An empty node. added core 3D node outline interface? Or is that, okay, so let's see if we can work that one out. So add render graph node. And this is called on the sub app render app. So let's go back to a little test function. Go app, which is a mute app, like so. We need to say app dot render, what was it? Sub app render app, like so. Then we dot add render. Okay, so add render node. Okay, so we need T, a node to be rendered graph, creates node using the from word implementation, adding it to the graph. So subgraph node label. Okay. So sort of there. I don't understand shaders enough to be doing this really. All right, we're gonna go with it's a live stream, so let's do things quick and dirty that doesn't actually need to work properly. So we're gonna go, hey, PBR material. So I want to reveal you an explorer somehow. How do I do that? Okay, fine. We'll control A, control C. We're gonna go shader. We're gonna go mod PBR, like so. Yeah, shader PBR. I'm gonna paste all this in here. Then we're gonna look around. I'm gonna go. So you do all this fancy stuff. You got 2 UV channels. So we're gonna need bit flags, which is not much fun. Adding all these dependencies. Any version. Okay. So you then have the standard material, which does all that fancy stuff. In theory, I don't know if I need all of this. I've done this before is the annoying thing, so I know. Shader ref. Okay, so you're somehow... Yeah, this isn't gonna work, I don't think. Like, I kind of just want to override this the shader, which is interesting because if we can... There's a shader ref here. Can I like override that shader? Why is my F12 not working? What is your problem? It's probably never gonna fucking... Okay, shader ref. Default handle or an asset path. Okay, so when we use the shader, that's the real question. Okay, so we're gonna go shader calculate and calculate tangent. How to calculate tangent in the Bible. So okay, so a normal cross with that one. Okay. I don't know if that's correct. There's definitely a way. So if we go to first, Let's track down Bevy's PBR. No, that's our PBR. Shader. So we want to go here. Okay, so I don't remember how to get this to reveal an explorer. How do I get here though? I don't want to be digging through my directories on stream. The users, Fox, cargo, registry, SCR, index, PBR, SCR. Okay, so in here is like shaders, isn't there? Maybe it's back here. No. Cluster light. Where do you load that from? Sign, so script. Lib. So you make all these constant handles. Okay, so it's in render. Function handle. Fragment handle. Okay, so it's render slash fragment, but is that where I just was? Like, is it in here? Render. And then one of these is called fragment. The issue is I'm going to have to rebuild everything. PBR fragment. Okay, then we go in here. I'm gonna. Can I open it here, please? Yes, open. We should probably add the extension for WGSL. Okay, so somewhere in here, there's like a main. Right? Or is it called fragment? How? I know you're in here somewhere. Where does the function start? PBR input from vertex output. And view binding. Okay. And if prepare. Okay, so we say PBR underscore input dot world normal equals none of this shit works because of how Bevy goes about doing this stuff. I don't think I can just say I don't know how to make a vec3 and any of this stuff. I don't like WGSL. Don't use it enough. W. Oh, that's probably it there. So no. WGSL. Fine, if we go to GitHub, maybe my repositories. I'm pretty sure everyone who's here watching me mess around doing God knows what. One of these is now I'm 90% sure the version I've committed to GitHub has it. Game. Mesh gen, hexagons, waveform, mesh gen. Assets. One of these should have like a shader. It's probably not custom material. Maybe it is. Maybe that's how I did it. It's possible that this is just how I've done it. Where do I calculate those normals? Fragment. There was somewhere. Okay. Why do I just set it? Is that the correct thing to do? No. It's new. N.v. Don't think this can be it. It's got to be this PBR. This is the really complicated thing. I reckon it's this bit here that I did. See, because I set let world normal equal that. And then prepare world normal. We pass in our world normal. And I reckon that'll be the only difference between ours and theirs. Okay, so is that gonna work? Who knows? Terminal. Alright, so then we have to do the annoying thing of going cargo clean and have to recompile everything because I can't get it in a position where it'll detect the changes, which is just a pain in the ass. Which then means we need to recompile everything. Is there a way to cargo clean just a specific file? I don't know, because I could have just specifically cleaned Bevy PBR. But those that aren't following along, instead of using the normal given to us by the texture, or like by the mesh, we're calculating by using the world the in dot world position XYZ and the in world position XYZ without whatever dpdy and dpdx are. I don't know what these are. Hopefully they're not functions that I declared in that class. Let's just make sure. The way they're laid out makes me think they're not. dpdy. There's only one instance of it, so it's obviously a built-in function. And then we're taking the cross product of those two, whatever the hell a dpdy is, and then we're normalizing that value to get our normal, which should, if everything works how I remember it working, apparently it's through an error. How? I didn't change anything here. What's even stupider, I didn't change anything and I just recompile it again and it's working this time. Got past it.
Okay, so what we're doing is instead of using the normal that is provided by the mesh, we're calculating the normal based on the direction that the triangle is actually facing. So it means that our normal will always be the tangent to the face. So no matter what, if we're rendering this point here, it's using this normal, not this normal, that normal, or whatever the interpolated normal is. It'll always point 90 degrees to the direction that the face is leaning. That's assuming it works, which means that with flat lighting, you actually end up with these two, like these are different shading, whereas at the moment they're the same color because no normal is provided. We may need to provide normals for it to work. Like, I don't know if the shader doesn't compile normals if the normals aren't present. That's entirely possible that somewhere down here it goes like if normals, at which point we can just provide normals. Where do normal? If define. Ish. Okay. Interesting. Okay. So first thing I'm noticing is everything's invisible, so it just didn't work. Now my guess is that when I go in here and I scroll back up, it's probably going to spit out, say it's going to spit out an error. That's our compiling error. These are all run errors. Where's their first line of code? So nothing went wrong. Here, error. Expected semicolon. What do you mean? Did I edit something? What do you want? PBR underscore input. N. Why do you if load? But I didn't touch anything here. Why are you having an issue? That's bizarre. Yeah, and we're in an end if so. Can we just comment that line out? I don't think it's going to recompile though. Yeah, so you immediately throw that error. Okay. Wait.
Why have I got this here? That's probably what's wrong. So can I cargo clean bevy is there something I can do? Dash help. How do I clean just one? Clean, remove the target. How do I get it to rebuild just one? Cargo clean single package. Options is okay, so it goes -p. So clean dash. Okay. Now if I run that. So I somehow duplicated a line of code. I'm not sure. I must have typed that and then copy pasted something. It didn't like me adding an analyzer. It's probably because of all the like defining and declaring and hey. Okay, so it's loading in, it's still not rendering properly. Now that probably has something to do with the value being normalized, maybe, I'm not sure. Alright, let's disable you. Because that becomes really hard to read. So we work out the normal here by taking the world position. Pretty sure that's the only thing I did. Right, because I've also like stripped away a bunch of stuff as well. So that's the only other place I use it. Well, apparently that's not going to work. I thought this was going to be a simple thing to implement, but it's not. So we're just going to say I can stay there because I don't think it's going to have any impact on anything, and I can't be bothered recompiling everything again. Don't save that. Go back to our main and just get rid of the shaders stuff. I'll see if I can get it working in my own time. Anyway. So, what are we working on? We're going to need to add to our map objects that aren't like the cells so that you can place like power poles on any tile. So the first thing to do with that is to go here and go, hey, we are storing. Why are you crashing out again? I don't know what causes this. For some reason my Rust analyzer is just getting stuck. Yep. Does that restart VS Code? Now the issue with this is that another project which requires VS Code to be running is don't mind this, we're just restarting a server because it needs to be running, otherwise the project doesn't continue. open folder here, YouTube, projects, untitled does again. Yep, hopefully that fixes whatever's wrong with my Rust analyzer. Yep, shaders is gone. Goodbye. Shaders is gone. Thank you. So we need to go to here. We need to go find wherever we've got map. Case sensitive, please. Map. Okay, that'll take me to it. There we go. So ID to entity. So here we're going to need to define a new, and this is going to be called a cell. And the cell is going to consist of the ground, which is going to be a term entity, and also a I don't know what to call them. I want to call them a scenery, but they're not really scenery. Maybe we'll just call them objects, which is a different entity. Right, and then you don't store this anymore. You store a cell. So ID to cell. So, and then down here somewhere, when we say get cell entity, self.id, okay, cell.copied, dot map c, and then we say c dot ground. So I don't think we need copied anymore, like that. So it's less, so it's more like get ground entity. And then we need a new one of these. It's gonna be get except object, I think, can be optional, which is going to be some c equals this c dot object else none. Oh, like node none. Okay, cool. Now we need to do some fancy magic of going not get cell, it's get ground. It should work fine. Map editor is going to work the same thing. We're just going to have to replace that with ground and go up here and replace this with ground. Oh, that's not useful ground. Okay. So let me come down here. There you go. Okay, you're also ground. We have lots of places where we use this function. Why did I not just F2 it? Up here. Okay, then we need to go here. We need to say, hey, when we insert this, we actually don't insert. We say okay, so next we need to go if world.get terrain type entity dot is thumb, then it's cells dot entry ID dot word insert cell, and then this is entity default. Does entity have a default? Apparently not. Placeholder? An ID with a placeholder. This may or may not should be overwritten in a before being used. Okay, cool. That's cool. And then this is just none. Right. So we do that, and then we say E equals. Let me say E dot ground equals entity. Else do exactly the same thing. It's interesting because that does imply that you can have a ground state that's invalid. Anyway, and then use the E equals E dot object equals some entity. Right. Fine, we need to let terrain. And then if terrain. Now the annoying thing is we have to do the same thing again, but down here. Except you should be entry and you shouldn't have to well, if you're the terrain, you need to remove both. Remove wait, that's just remove ID. Like so. Okay, so we just remove that. We don't need to do that. Just if you're terrain, remove both, because for some reason both are being removed. And then otherwise get the entity inserted, otherwise, and then object equals none. Okay, this is a terrible way of doing it, but again, quick and fast because trying to stream, which means got to keep it interesting. So we can now add non-terrain type then. Okay, that's interesting. So what a terrain should do, I guess, is when I add a terrain type, this seems like a poor way of doing it. It should be fine. So hooks.onAdd. So what I'm going to do is make it that when you add a component with hex ID, it will work out if it should be like a child of a chunk or a child of terrain. Then from there, we need to go something like if terrain, then let chunk equal, we need the terrain chunk size. Size equals world dot resource. Yeah, chunk size. dot 0 dot get. Okay, so now chunk size, and then we say here, and we say id dot chunk is our chunk size, which gives us a chunk ID. Then we say if that some chunk equals, we need our map. Let map equal world dot res map dot I think that's it. Just do I not qualify map? Okay, let me say map dot get chunk entity dot get chunk dot clone. So we have access to map to get that entity. Then we say like world dot entity chunk dot child. How do I push a child? I say like world dot commands dot entity chunk dot child add child, and that will be entity. Else do the same thing again. Wait, no, this is otherwise, so this one kind of just want to be like one. Chunk not in map should be fine, like that. Okay, and then we say else if you're not a terrain, then we need to let cell equal map dot IDs to cell dot get ID. Okay, so this is if let some cell equals this and this if let cell equals cell, and then we say that ground equals cell dot ground, and then we say world dot commands entity ground dot add child entity, like so. Else one cell has no ground, which is ID. No, because that's two separate states, I think. I guess technically it's not. I don't know. Like that. It seems a bit dodgy, but it should work. So I guess next is to go to terrain and add kind of need to have like chunks need to have like a set of things, like a chunk. We need like a component up here. So there's the chunk D, and then we're going to say struct chunk meshes. Chunk mesh handles, and we're going to say main, which is going to be a handle to a mesh, and then we're going to have a power. Which is also a handle to a mesh. This would be so much easier if I knew how to do shaders, but I'm just going to be like really lazy with it and just brute force my way around that. So I'm going to derive, not default, just derive component. Like so. I'm going to both these public. That should work. So when we spawn in, we're gonna need like an enum chunk type or mesh type, I guess. Mesh type. Then we're gonna go. You're either a main mesh or you're a power mesh. Oh. Power. Good. Finally, brain working. So when we generate the mesh, we return this. Okay. I think this needs to be public at some point. So at some point we queue all the meshes to be made. So we're gonna need new module power. I really need to rearrange this stuff so that it's not all crammed into the same thing. Anyway, so on the chunks we'll put it hub mod power grid. So for now, power grid's gonna have one thing in it, and that's literally just gonna be hub struct powered. Like so. This is a component, derive component. Bevy prelude. So for now, we don't care. It's going to be powered or it's not going to be powered. Then we're going to mod here. Somewhere when we generate. So this is generating a chunk. Yep, when we generate a chunk, we call some fancy code. It's interesting. In theory, I could outsource the chunk generation to be asynchronous, but I don't think I want to do that. Anyway, children for child. Train, update train. Okay. So we just kind of want to go like. So this is for each child. Chunk to entity children. Okay, if you've got children, if you okay. So commands entity chunk entity with children. Okay, so I'm gonna say if map dot Do I have the changed data? How do I get terrain? Okay. So map descriptor dot sample hex, and we're just gonna pass in the hex. I'm gonna go if. Ooh, that's gonna be fun because if height. I don't want to power all the land. I just want to. I guess we're just gonna go with a random RNG. RNG. Okay, so that means we need to go up here and be like, let mute RNG equals rand. Do I not have rand? Am I just using noise? Huh. That's amazing. How did I make it so far without using rand? Weird. Rand, RNGs, STD, RNG, from seed, and then that's going to be map descriptor dot seed dot. Okay, what seed do you want though? I think you're going to complain about the seed type anyway. We're going to say RNG dot genbool with a percentage of like 10% will be powered. Else just continue doing what you were doing before. So if you get this, if you roll the 10%, you get powered. Okay. Right. From seed U64 as U64. Okay. Oh, actually, shifted 32 bits that way. Right, I think that should work because technically the seeds are U32, right? And then we can OR that with chunk.q as U64 XORed with chunk.r as U64. That should work. Why are you not working? Is it because we need to do this? And then this. Okay, so we're taking the seed, we're shifting it 32 bits over, and then we're XORing Q and R together. And then ORing them with that one. I don't know if that'll work, because technically I think -1 might cause it to be an issue, but it should be right. That should mean that every seed has a random value. So next, we need to go to where we generate our meshes. So now the issue with this is we're going to be generating twice as many meshes per frame thing. So it's going to technically bog the game down more than it really should, because I'm, again, not doing this with shaders, and it would be so much simpler if I could just, while I'm generating one mesh, set a parameter like this mesh has power or this mesh doesn't have power, instead of having to generate two separate meshes. Okay, start mesh tasks. So the task pool will technically be two separate tasks. So because we're going to be generating twice as many meshes, we're going to drop down the number of meshes we generate per task. Next, we need to go up to somewhere we're storing all of these, right? started. Yeah, but where do we actually mesh tasks? Insert. Okay, so we need to track down where we're doing mesh tasks. Mesh tasks here. So mesh tasks is actually going to be a tuple of option, comma. Ooh, it's a bit ugly. Is that correct? 1, 2, 3, 1, 2, 3, 1, 2, 3, 2, 3. And then a closing one. Yep. Like that. All right. So go down here and then we say, instead of doing this, you're when we extract everything, don't we? So we want to grab an option powered, like so. Okay, so then you're grabbing this and we're going to go powered. We'll just call you P for now. So when we get to here, we need to go, hey, we need 2 of these. We need to go this, like this. Then we need to go sum. Getting very, very complicated for no real reason. So we need 2 copies of data. So what is data actually? Okay, so we need a data and then a p data, right? So then we go here, and we say powered gets its if p dot is sum. Then your terrain type is terrain I don't want to just do powered because powered overrides the actual terrain type. We don't want to do that. We want to say leave terrain type the same. It's, I guess, connection should maybe hold that information. Yeah. It's because I'm trying to override this. So you take in a data and a mesh store. The data is the hexagon, the terrain type. I guess we can say this is an option. UV rec, no, UV type, right? And then we say data, override. Wait, is override actually a keyword? That's interesting. Anyway, you do this, you match terrain. Then we say if sum ride equals override, then we say color equals override. So we need to make u-mutable. Okay. If sum, if let sum override. Okay. So if we pass in an override color, we override it. So each of you, so you just need to say none, because at no point do we override your color? And then here we say if P, then we say sum UV type yellow, else UV type, I don't know, I want to just say rock, because like it's just going to be gray then. Rock. So, and you're not data, you're P data. You're P data as well. Right, and then your mesh, your P data, like so. And then somewhere down here we when we end our mesh task. So first thing is finished. That's interesting. So we're giving it to each chunk entity. So then we're saying if the task is finished. So I need to split the tasks up. Right. So you're then a vector of entities. Okay, so can I filter sum? This is task 1, task 2. Then we need to say something bizarre like if let sum task equals task task dot is finished else if sum task 2 equals task dot task 2 task dot is finished. Wait, what? Why is none is sum? Yeah. Why can I not is finished here? That's weird. I think else false. Somehow. Okay. Can't. If let. Okay. So then some task. Okay, wait. So then we want to go. If let some. I guess okay. We'll make them non-optional then. I was making them optional because I was thinking you can finish one task, then you can finish the other task, but I'm thinking it's probably going to be easier to make sure both tasks are done before you complete the mesh. So up here, just say it's just task 1 and task 2 now. Because that means all I need to do is go down here and say task. So we have task 1, task 2, and we say the answer to this is task 1 dot is finished and task 2 is finished. See, because that really simplifies that logic, because instead of being like check to see if the first task exists, check to see if the second task exists, work out your result from there. It's like, no, if either of the tasks exists, so then we can go, let's sum task and task 2, and then we go here and we say, get task 1, and then this is mesh 2, so this is task 2. Then how the hell are we, so okay, mesh get mute chunk. Okay, so we don't want a chunk itself, we want it was chunk mesh handles, and then to you are this, and then we say dot main, and your dot power, and then at the end here, well, we probably want to grab the ID as well, so mesh 3D. So then we want to probably go up here and annoyingly have to make even more of a clusterfuck and say state map view. So we're going to have normal, and we're going to have powered, power. So we have a normal view and a power view, and then we're going to need to initialize this. Yeah, this whole thing needs a cleanup. Init state map view, like so. So initialize our map view and powered. Then we're going to have to add a function at some point to change between them. So all we do here is we say I feel like I want to do that elsewhere. Like I want to have a separate query. There's no real reason to though. So it's kind of like, so that's chunk and current. So we need access to that state. So we need state map res state map state map view. What did I? Yeah, map view. Okay, map view, and then we say if map view or state equals map view normal, then current dot 0 handle equals. So we're gonna need to keep a hold of that. Put that there. Let me say 0 equals handle dot clone. We're not clamp clone. Like so, and then pass the handle there. And then we need to do exactly the same thing. Apparently, oh, it's got to get, isn't it? Like that. So, because apparently you don't need equal. Wait, but you've got equal and particle. You're driving me mad, you are. Is it map view more equals? Can I only compare in that direction? No. I have to dereference it. Weird. Okay. So then it's probably faster just to copy this, paste it here, and then tweak the two values that matter, which is that you are power, and you're also power. Why did I make you mutable? I have no idea. Okay, like so. We never finished task 2 because we copy pasted that back over that. Okay. Okay. So that should load the two powers up. So then the final thing to do is add a simple function that lets us swap between the two power modes. So we'll go right down to the bottom. Swap map view, which takes in input res button input key code, and also needs next, which is res mute next state map view. Because it does next means it needs current, which is state map view. So we come down here and we say if input dot just pressed key code. We can actually make them hard coded. So we're going to say we don't need current. I'm going to say if you hit key code F8, we're going to say next dot set map view power, and then if input dot just pressed key code, and we'll go F7 next dot set map view normal. Okay, so that's our spawning of our maps, and then we need to have fn set mesh view. So we need to iterate through all of chunks. So chunks, which is a query for mutable mesh 3Ds. Mesh. No, we need a reference to the chunk mesh handles, state, and that might actually be it. So for mesh handles in new chunks. Need you to be mutable, need you to be mutable. If match state dot get. Okay, so normal means that mesh dot 0 equals handles dot main dot clone, and power means that, well, probably try and give it a bit of a better fighting chance of optimizing this away. So then handles dot power dot clone. Okay, so then we need to go to update. So we need to go add systems on enter, view, map view, normal. I feel like that's the wrong way to run that. It should be more like if state dot changed. Okay, not changed, return, then go here, and then they go, hey, these can both just go and update. So we need to go set mesh view, and was it change mesh view? Change, no, what did I call it? Spawn map view. That's definitely correct. Spawn map view. Set map view. Go up here. And this should actually be set view mesh. So it's a little bit more intuitive of what it actually means. Let's go. It's been a while since we compiled. I'm a bit worried that this is not going to work, but we'll find out. So, if you didn't follow along the whole way, or if you weren't here when I started doing this, what I'm currently doing is generating a second mesh that indicates the powered state of a particular tile in the world. And the way I'm doing this is basically when I extract the information, if you're generating the powered mesh, it checks to see if the tile is powered and sets the override to yellow. Otherwise, it sets the override to gray, and then generates an entirely separate mesh using those overrides that when we're in mesh view power will basically render a gray yellow version of the map versus if we're in normal mode, it'll render like a full color vision of the map. And these two meshes are saved so that it should be fast in theory to switch between the two, and we'll only have to update the chunks as you actually draw them, which means that it'll be slow to run the first time because we're generating twice as many chunks, but it should be fast to switch between. Simply because all it does is just swap which one is currently being viewed. When we finish generating the chunk, I'm pretty sure I set it to look which state we're currently in and set the correct state so that they shouldn't end up out of sync if you change it while it's generating them, because it's like when it's finished generating, it looks which one it should set as the primary one. So first thing is apparently we see absolutely nothing, which is concerning. Failed to find mesh. Wait, what do you mean failed to find mesh? Well, that's interesting. First off, who's writing the error failed to find mesh? I'm pretty sure that's me. Like, that's my compile error. So we need to search here and go, fail to find mesh. Nope. 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 In terrain. Failed to find mesh. 4. Okay. So we never gave them chunk things. So when I say chunk ID, right, so we go back to here, we go chunk, we go, hey, chunk ID. Ooh. Yes. Not much fun. Dot register required components, and then it's TNR. Okay, so the required components for chunk ID is a chunk handle meshes. We can just say that you have default as an option. Okay. So it's just that it couldn't find them because they didn't have the handle attached, which makes sense. Notice one of the smaller issues I was expecting to run into. Interestingly, we're still generating like 50. Nah, it's definitely taken longer. We're generating 50 chunks, but that's the invisible chunks. We're not rendering 50 meshes. Boy, is it dropping down to 8 FPS. I don't know why. It shouldn't be affecting the FPS. This is why I don't trust Bevy's async. For some reason the async is not actually working properly. Because in theory I shouldn't have lost any frame rate because it just will take twice as long. But like it actually seems to use, I guess, the same cause for the async as the not async. Anyway, if I now hit F8, they go to the power grid. See? And all the yellow ones are powered. Okay. Interestingly, water is still water. I don't know why that's the case. It's because if I go over to Blender, the water tiles here actually have their material set as water, not as main. And the way that we set the color is we set main. So basically that's saying you can't power water. Water can't be powered. Or doesn't render powered, which is fine. It's not required. So at the moment we're like a 10% power chance of a cell having power, but that's for testing purposes. So next, I guess we need to add some kind of way of adding like power poles, which one of these? Not that one. Oh, well, that's interesting. This is why I was trying to get the shader working earlier. You can't see these because they're the same color as the rock. They should probably have their own color, but that's besides the point. This probably shouldn't be placed in 3x3 arrangements. Okay. So this is an actual tile, which is not how this is supposed to work. Next is, I guess, to get the power grid working. So the interesting thing is about power. So we have a struct powered, which we can attach to any cell if we want to make it lit up when we enter the power mode. The other thing is that doesn't seem to be updating the, I guess we're technically not setting anything. Yeah, I was going to say it's not updating the power, but of course it's not because we're not actually setting the powered state. So we need a struct, so we're going to call this like a power pole. And power pole. We could just say that a power pole is just a thing that gets done. And we'd say a power pole does some fancy stuff. The power pole is going to say derive component. It's also going to require a hex ID. Why can't I get a hex ID? If I use crate preload, where's hex ID is stashed in there somewhere. Yep, okay. So we can give a power pole a hex ID. Now the issue is that a power pole is not a terrain type. So somewhere I have map editor. One of these is called like map editor. In here we have a line tool. Then we have a fill tool. I guess we'll make an object tool, which is just going to use the same logic as the fill tool. So copy that and go paste it here. Except you're an object tool. Object tool. So I'm wondering if I should maybe not bake the objects into the mesh. That would definitely make rendering them easier. And then I could just change their material. This is object tool. So we'll go up here and we'll add a new type of brush called object. Then we're going to go to wherever our plugin is. We're going to say you're active when fill tools around you're active. You're the object tool. Oh, fill the whole thing up like that. That's a bit. And yeah, object. And then to tweak which one we start, we're just going to say, hey, like maybe make the default the object tool so we can have the object tool selected. Now, how do you work? Who knows? All right, so starts.read data.active. Okay. This is something I noticed on my line, my fill tool as well, is it doesn't care what button you pressed, which is not correct. We need to say, hey, let's just say don't activate it until you actually get to the activation point. That's a good idea. I don't think I ever read what brush it is, so we say if start dot button that does not equal pointer button primary continue. See, because what was happening before is you could actually like you could use the middle mouse and move the pointer around, which is not intended behavior. So we're just going to replace this piece here like so. Okay, so do that, grab the center, work at the center. This one I don't think is going to have a brush size, so you can just ignore the brush size. Objects are only going to be placed as singular objects. So for hex in, okay, so we can get rid of this whole thing because this is about filling in the area. So we go center, we pass in hex, which actually I think our object tool maybe shouldn't be draggable. So data.active. Maybe we'll leave it because otherwise I have to work out how to do other stuff. So then it becomes center. You could just rename center to hex. Thank you. Last equals hex, please. All right. And then if going up to the trend. Okay, so this is where it does it. So we map up at hex. So I think here what we're going to do is we're going to say cells. Okay, map get. Okay, so this is get object entity. So this one, instead of saying nothing, we spawn it. So you're doing fancy stuff. So I reckon what we can do is we can say, hey, if you find this entity. Okay, then we're going to say, do we have access to commands at this point? Grab access to commands. So we're going to go here, we're going to say commands.entity, entity, yep, and then .insert PowerPole. Okay, this is a pretty dodgy way of doing it, but anyway. Then we're going to say commands.entity, no, .spawn, and then we're going to say it needs to be a hex, right, and a PowerPole. Now, we also want to set your material, I think. So, not cells, it's Well, first of all, we rename you to objects. And you're not terrain type, but instead you're going to be, I think, mesh 3D. Okay, so then you insert power pole, but we have to go here and we have to say something like okay. Mesh equals objects dot get entity. Okay, so we're going to get the entity, and then we're going to say, well, first we to get mutably. That would also help. Like so. Make the mesh mutable. We have access to the asset server at this point. No, asset server. Res asset server. So then we're going to say mesh dot 0 equals asset server dot load. Now we're going to load object dot obj hash power pole, and then we get to do the fun thing of designing a power pole. So that you do that else commands dot entity dot insert mesh. You shouldn't be able to do this, but anyway. Well, since we did it in like 4 places, we should say somewhere we also have material. Not sure where I get the material from. Main. Where do I pull material from? Terrain material. Was gonna need that, thank you. I think that's super, isn't it? Super. I haven't really considered events, mostly because I find events a bit cumbersome to use. I didn't think change detection was particularly slow. Because the way it does change detection, I think, is like 0 cost or whatever, in that like it keeps track of everything that's changed anyway. So it literally just goes, hey, these components have changed. Like it's just comparing like sets or something. I'm not sure. It probably is slower, but I'm kind of trying to get things working rather than trying to make things efficient at this point. Simply because I'm really bad at finishing projects, and if I spend forever trying to make it optimal, it just won't ever get done. But yeah, events are probably a smarter way of doing like single use. Like I'm spawning a thing, triggering an event, rather than doing change detection. So just handle. So otherwise insert it. Handle and then else. Mesh 3D. Handle and texture. Material. Not 3D. Mesh material 3D is material. The fun thing about Bevy though was it's so fast that when they say it's slow, they mean like you would be querying tens of thousands of things to even notice the slowdown kind of thing. But you're probably right. It probably is slower than events. It depends, I guess, on what kind of change. Like if you're expecting a change to happen every single frame, then it's probably faster to use those than events, because events also have a lot of bookkeeping around them in that they need to track. Like they have to store the events and you have to iterate through all the events and that kind of thing. But I wouldn't avoid them. Like seriously, Bevy is so fast that unless you're having performance issues, like don't avoid using something because they've said it's slow. Like they like something I was reading in the 0.15 update logs was something about if you were running table queries and sparse queries, like or components that were tabled and queries that were sparse, they were slow, and it was like I don't know what the performance things was, but it was something like you wouldn't know that you were doing this unless you were querying tens of thousands of objects. And it was more like if you queried two tables, it was fast because it could just like line the two tables up and get them both. Whereas the one had to look up in a set and then can work out in the table. So it was like it was only slow in these specific conditions that most people would never run into. But Bevy was like, it was too slow, so we made it better. So yeah, Bevy's pedantic when it goes to like, hey, it's slow. It's like it doesn't actually mean it's slow. Avoid it. Like Python is slow. Bevy will never be as slow as Python, and yet people still write games in Python. So I think you're fine not avoiding anything. My favorite one was I spent ages trying to work out how to optimize my code. Then I ported to 0.15, and it was like it just runs so much faster. It's so much faster. So much so that it didn't matter how many chunks I tried to render, it was rendering like above 60 FPS. What have I done wrong here? Else. I think I'm calling an else twice. Yes. I think your if some entity, else spawn the entity. Okay. And then, yep, and data end active, data not active, return. Right, and then you just run the same code again. Okay. So that's last equals center. Nope, don't backspace it. Nope. Okay, let's just get rid of that. Rename it to hex, and we should be good. Nice click and drag. Okay, so we don't use the chunk size. Okay. Why was I using the chunk size before? What the hell was I using chunk size for? Weird. Were you not actually? No, you're using chunk size for something. Chunk size to tell it to upgrade. Okay, well, I'm not doing the update hex anymore. Matter. Okay. You don't need to be mutable because we never call update on you. That's fine. Yeah, that's fine. We don't need to worry about that for now. Okay, so the object tool, we call that. So the next thing to do is to grab this and go, hey, we need to make that power pole, but I need to use... Well, actually, technically, I'm already using the correct things, I think. So trick one is going to edit the power pole. Select all those, delete that. Delete faces. Power pole doesn't need that. Okay. Then we have a little wonky power pole that you won't be able to see if it's standing on stone because we don't have normals. Maybe I should be exporting normals, but anyway. Then we're going to just call you power pole. So, and then we're going to go turn this off, grab this file, export object, and this is going to be objects.obj. Export that. So there should be a power pole, And then you're going to have issues, aren't you? Yeah, mostly in that you need to have a transform. Wait, no, the Mesh 3D should take care of all that stuff, though. Let's just find out if this works. Should. There's no reason this shouldn't work if I've written my code appropriately.
It should detect the hex, move it to the right location. It won't set the right Y location, so it's probably going to clip into the ground,
but that's going to be fine. We should be an object tool. Ooh, something went wrong. Okay. Why did you complain? Warning, global transform component has parent without global transform. Okay. Now, how did that actually work? That is the question. Well, we placed a power pole inside ourselves. Well, apparently the power pole is just always going to be placed at 0, 0, which is incorrect. Thank you. But, thanks for trying. All right, because they're never giving you a location, but it's going to be laggy. All right, they're just all spawning on top of each other. That should be fine. Why are you not getting put in the right location? I am giving you a hex. Okay, let's try and track one down. If I click like right here, which apparently puts it right in the center, which is incorrect, but should be easy to track down. Not node. Whoop, we hit a crash. Okay. I think that's to do with the editor, not anything I was doing, but we open you. Yep. So the editor's causing a crash, which is obnoxious. All right, we need to go to our hex ID and say, hey, just don't child things automatically. I thought I was being clever, but that seems painful. Well, yeah, that's fine, because it's on insert that we add it to the map. So that's the auto childing code on the unadd. Mostly because I thought, oh yeah, it doesn't need to be rechilded if it's already a child or something else, but what that just results in is just things becoming difficult. Okay, so when I place you, okay, and then we say, ooh. Okay, that crashed again. The editor keeps crashing. That's not fun. Okay, it's going to be that entity. Yeah, that's the right entity, but I can't get to it because the editor keeps crashing. Fine. Can we we'll just add like in power grid. Can we add like a input res button input key code. We need to query all the transforms with query transforms with power pole or pole in query print line pole if not input dot just pressed key code F5. Okay, can we add our power plugin, please? So pub fn plugin app app app.add system update power pole. Then we need to go back up to you and say, hey, can you add the power plugin? Add plugins power. Power grid plugin. Default debug. Okay, like that. Run that. So now when I hit F5, it should tell me where the power pole is placed, so I don't need to open the editor. Not a very useful editor that I can't actually edit anything, but I don't know why it crashes. Annoyingly, if I hadn't started the stream off by trying to make shaders work and had cargo clean, it would still work because the editor it's only broken in like newer versions. But anyway, F5. Maybe we should have waited. Oh, we have to also spawn a power pole. That would also help, wouldn't it? What? Why are you working now? Right, fuck you. I hate you so much. Okay, so hilariously, just absolutely hilariously, when I write code to try and debug it, it works. So just ignore me. Back to F7. Okay. So next is, I guess we just apply power. So to apply power, we need to query for the XID with power pole. And then we need to say added. I guess we don't need to say with power pole, added power pole, just added power pole will do. Power pole. Okay, so if you added a power pole, we need to... Why is there a little Copilot button up here? Are they giving Copilot back away for free? Oh, I'll look into that off stream. Okay, so power pole. Query added power pole. We need a map, which is resource map. Okay, like so. So we also need to be mutable, I believe. Because I need to be able to. So you're called apply power. Apply power. Okay, so let's make a const power range, which is an I32, and it's equal to 3. Technically, the power pole should probably hold that information, but anyway. So for added in query, so we can get the hex ID. Then we say for hex in fast iter no. Ooh, we need a dynamic fast iter. Actually, technically, we can just use the fast iter because it's an I32 constant. Actually, is it the other side? It's here, isn't it? We say power range. How we do it? Okay, like that. Right. So now we have the power pole, the fast iter. We need access to commands, don't we? See, the issue is whenever we remove a power pole, it's going to be hard because would need to check to make sure that there are no power poles within the range to repower the thing. So that's going to be a pain in the ass. So we're gonna get I'm just trying to run this through in my head. How will we remove power poles? Well, the answer is we won't, but so we need to say map dot get ground entity. Okay. Then we say let's sum get the ground entity. Don't worry about anything else. I guess else continue, because if it's not there, it means you're probably on the edge of the map or something's broken. But we're not going to print it out because otherwise it'll print out like everywhere when it's wrong, and it bogs the game down to a crawl. Then we say commands dot entity id dot insert powered. We need to say dot with offset. Like so. Okay, and then we're gonna say map dot change update hex. So we need the chunk size as well. Chunk size, which is res chunk size, like so, chunk size, and then dot get. So we say to update the hex, because then we know what it's going to do. I mean, it should work. Again, we're not going to be able to remove power poles because we have no way of detecting whether there's another power pole within range that would then repower it. The lazy way around that one would just simply be like once per second update the power grid, like clear all powered, recalculate powered, and it depends on how long it takes to update all the power. The issue with that is redrawing that mesh every time. Anyway, if we go F8, see, now you like bring a power around it. They're powered. Now, the issue is that the power pole just powers, like it doesn't have any kind of like use, like you don't need to make sure that the power pole has enough power. It's just anything within a range of a power pole is powered. So I guess next would be we can also just place lots of them. So I think next we want to jump into first of all, let's go down here and let's rename some of these materials. So first off, water is just called blue. Thank you. The issue with this is we're not using textures at all. Everything is going to be mesh level colored. So your blue, which also means we need to come down here and we need to say this is called blue. Bank is just going to be brown. You're gray. Okay, so you need to say you're gray and you're brown. Now, they're not the best. They will do. Nope, no. What do we want to do? We want to open Blender. The next is to make a new object, and this is going to be a solar panel. So now to make a hexagon, so mesh circle. Yep. Okay. So let's start by making you radius 1. That's the size of an actual cell. And then we're going to go into edit mode. We're going to shift, duplicate you, scale you down. I think we want 6 hexagons to a chunk. So we're going to scale you by 0.3 3. I think that looks like it'll fit. And then we want to like extrude you up 0.02, 1, 3 maybe. That looks good. We want to add materials. We need to grab the materials. We need to rename things like water needs to become blue. Water is blue. Your new material color, rock, is now grey. Okay, now we're going to assign all of those to being grey. And then we're going to go like so, like so, like so, like so. F, and assign that blue, and then A, shift N, flip all the normals the right way. Then we're going to go, I'm going to do something equivalent to F, E, Y, right, 0, 2, like that. And assign you to being grey. Oh, no, I need the face to be grey. Q. That face there is grey. Ooh, we can't be doing that now, can we? This is where using textures would be nice, but instead we chose the lazy approach. What we can do is grab you, move you up 0.001. I don't know if that's going to be too close, but anyway, we'll do the same thing over here. I'm going to grab you. We're going to go F, E, grab you 0.0 negative. Apparently it was a 2. Okay, then we're going to grab you, go that way, 0.001, like that. Then we're going to select this face, and we're going to go assign that to be grey. That looks like a solar panel, doesn't it? I don't know. I guess it's L. We need to probably put a face on the back. I swear I wish I was good at art. Might justify making my thing be able to use use materials if I could do art. Okay, so then we want to go grab you, move you up 0.2. Ooh, we didn't grab all of them. L. Grab. Go Z 0.2. 0.15. Rotate you around the x-axis 30 degrees. Negative. Okay. We're going to shift, duplicate, grab, move you here. So it's, I guess, 0.5. Shift, duplicate, move you 1 point. Whoop, that's not the right button presses. Grab, move you. Did I not end up duplicating you? Okay, shift, duplicate along the x-axis 0.55. Shift, duplicate you. Grab along the x-axis negative 1.1. Okay. I'm going to shift, duplicate you to, what does that look like? Interesting. 0.232625. Okay, first off, don't do that one. Redo that. Okay, apparently that doesn't work. Shift, duplicate, grab. Grab 1.1. Okay, put you down. Go, hey, is there a second one here? Yes, there is. Okay, so let's delete the second one. Just delete everything. Is there another one here? No, okay. So we want to go this one. Like, want to shift, duplicate you and go, hey, if I moved you over so that you were like right in the middle, what does it look like? It's 0.27, right? 0.75 maybe? That's looking about right. I'm going to shift, duplicate you up that way. I'm going to put you so you look about right, which is apparently 0.5. Then we're going to grab this one, we're going to grab you, we're going to go negative 0.5. Now, the question is, if we look from above, are they all inside? They aren't all inside. Nice. Okay, then we grab you, L, shift, duplicate, grab you. Ah, 0.5. Okay, so that means to place them at 0.55. Okay, so we want to start again, getting rid of these four, because that tells me exactly how much I need to move them. So I need to delete. Oh, not only faces, delete vertices. Okay, when you select you, shift D, grab you, move you 0.55, divide by 2. Did I do that wrong? Yeah, divide by 2. Okay. This is 0.55. 0.55. Why do you keep doing that to me? Why have you got this divide by 1? Why are you doing this? Grab, move you that way. 0.55. Divide by 2. Nope. Okay. Grab you, move you 0.55. Pop this open. And go, hey, can you divide this by 2, please? It'd been easier just to do the math. It's 2.75. Then go, okay. Grab, move along the y-axis apparently. 0.55. Now that feels like it's pulling you a little bit close to the line. Then that's a nice symmetry to it as well, 0.55. 1.1. Okay. So now we have a little like array of solar panels. Probably get rid of these. Okay. Now they probably need some kind of frame to sit on, otherwise it looks a bit dumb. But how would I do that? How do I do this? Thickness is 0.5. It's a little bit too much. 2. Yeah, that looks good. Then we want to E that out. Scale it in the Z direction by 0. And then set it Z height to 0. And then apparently we want to go back in here and we want to do that all again. Don't mind my stupidity. Delete all of these. Go hate you. L shift D, grab you, move you 0.55. Shift D, move you 0.55. Grab 2 of these, shift D, move them this way 0.275. Grab them, move them that way 0.55. Shift D, grab them, move them this way 1.1. Okay. Now we have a little array of solar panels as an object. So this is called. Okay. So then we want to go you and you. I want to go like export objects export. Okay, so did I rename rock to gray though? Who knows? Who cares? We go power grid. So we have a power pole. We're also going to copy this and go, hey, can we also have panel? That's probably spelled wrong, but anyway. Okay, now I need solar spelled wrong. Solar panel. There we go. Did I spell it wrong in Blender as well? Yeah, solar. Oh, wait, solar. Okay, yeah. We'll fix that. Solar file export. BJ. All right, so solar panel. Okay. First off, your name is apply power
So what to do next? We need to
solar panels, and they need to like generate powered. So we need like a resource that is power grids. Drive resource struct power grids. Right, and this is just going to be a hash map of like a U16 maybe, U16, and then power grid like that, and we're going to struct power grid, and a power grid is going to have like a generating. Generating, which is going to be use 32 using, which is a U32. I'm trying to think how to do this. But yeah, they're generating and using, so first apparently you're inserting powered, and then you have 0. So the first thing I should probably do is get a power pole to query around itself to work out which power pole is the most powered, or like the nearest, nearest. Yeah, okay, so let grid equal 0 for you need a 16. We need to turn you into a structure so I can remember what this is actually for. So next. Okay, and then we're going to say your grid data. So, okay, so then we need to init resource power power grids, and then we need to implement default view, import default for power grids default. So power grids, so next is going to be 1, and grids is just going to be a hash map default. So okay, so for hex in ring iter new. Ooh, what do you mean size? Your radius is going to be power grid power radius. But what is your size? Oh no, right. Wait, what? Oh no, that's a chunk iterator. No, it's not really, no, it's spiral. with a, yeah, okay. Power. Power range. Okay, so we have a power range, like so. So what this is, we need to give it a width offset of center. So width offset added. So what we're going to do is we're basically going to scour all the cells starting from on top of our cell, spiraling outward until we find the next like grid with the power cell. So we need to say so powered, and that's powered by, but we don't want powered. Well, I guess we do want powered. We want to know. So we would need to query the map. Because we only want the power poles. No, so this is 4 power poles. So technically, other like solar panels would also count. Possibly. Not really, because you don't want a power pole jumping on the power grid when there's a second. Okay. So we also want to go like poles, and this is just going to be a query, blank query with power pole, like that. This is so we can check what poles, like whether it's a pole that we're querying. So then next we need to go let some entity equals map dot get object entity for hex, right, like that. I'll continue, right? And we say if let some wait, we can grab our powered, can't we? Okay, grab our powered, and then we say some, and then grid equals poles dot get dots. Okay, so get that with our entity. So then we want to say grid equals power dot 0. We're going to make grid mutable, and then we need to break. As soon as you find a power pole that's nearby that's on a grid, break. Then we come down here and we say we need to let mute. Mute power grids, which is a mute power grids. Like so. Okay, so we say if grid equals 0, power grid dot new grid. Grid equals power grid new grid. And then we go up here and we say, okay, so let's import power grid fn new grid, which is going to take in itself, and we'll return a u16. So we say self dot grids dot insert self dot next maybe we should say this is +1. then you could start at 0. And say, let's like self dot next plus equals 1, and then you say self dot add self dot next and a power grid. With a generating of 0 and a using of 0. Right, like that. And then you return self.next. Okay. Did I name it wrong? Grid. Thank you. All right, new grid. Grid equals this. Okay, and then you are powered by grid. This is also spelt wrong. Power. Okay, so cool. Now we need to poll by poll, and then we just say fn apply panel. Which is do exactly the same thing as applying a poll. The panel. So except you're going to be query for added solar panel. You'll still need to query for polls to work out which grid you belong to. You can query for the map. You can query for the commands, chunk size, power grids. Except you don't do this bit. I don't think you want to do that either. I think you just set yourself to 0. Apply panel. You're in panel. Okay, so we work out what grid you are by doing that. Okay. Technically, I think you want to go. So if grid for hex. Query mute palette with solar panel. We say to be you're only powering this is powering all the ground tiles, which is fine. It's right. So yeah, you can just power the ground from whichever's closest. I want to say let some. So you do that, and you do that, and then we say id equals map.get object entity hex, right? So there's an object there. Oh, no, okay. We want this if let sum. Don't continue. Do this, but don't continue because we need to do both. Then if let sum. Do this one, and then there's this command if okay if let okay power equals panels dot get entity well, no, we need to get it mutable here. Okay, and then we say yeah, this is where a shader would be really nice because I could just give a different color to every power grid and I would know if this is working. Anyway, so if let sum get object entity hex. Okay, and then if hex equals to be a panel, and then we say if power 0 equals 0, then power dot 0 equals grid. That's because it's ID. Thank you. I make you mutably. Okay. And panels is not borrowed mutably, so I can't do that. So mute. Except, all right. So we update panels when we place a power pole nearby. If there's a panel nearby, we do that. Okay. So then next, you need to do this. And we say, hey, you iterate through, and we say, hey, grid, and then we say for nearby, work out the nearest grid that you can connect to. See, I feel like we should be inserting because then we could use the powered to dynamically update the power grid saying like, hey, this thing lost powered to you, so you lose what you generate, and then yeah, we should probably do that. So don't grid power 0, a new grid. So when you do this, you should always be inserting. Then so instead we call commands entity ID dot insert powered grid. So the power doesn't be mutable anymore. We literally only need to know if it exists. That's interesting. Okay. I guess without power pole, just so they don't conflict. Because power poles will always make a new grid. No, not with offset, without power pole. Okay. We just get you. Okay. Okay. All right. So for hex, and then just get object if there's no object, we continue. Then we find a powered, and this is power poles. Yep. Okay. And then so we say let okay powered, and then we snatch it onto your grid. Okay. Otherwise, grid stays equal to 0. Cool. I kind of feel like you should make your own power grid if you don't. But I feel like I'm going to end up with like a lot of power grids that have nothing connected to them. Because every time I call new, I don't reserve and then unreserve power grids.
Could do like a reserving and unreserving system of like request a new power grid, it'll go through, find the next power grid that's empty. So
I should probably also rename powered to grid instead, but we'll work on that. So let's just rename this to next empty, and then so your power grid, and you're going to say connected. Connections, and it's going to be 0, and we need to go up here and say connections. So 0, not 0, it's U size, I guess. And we say here, we say 0. You mean, oh no, you don't go on that one, you go on that one. Oh, okay, no, where the fuck? Okay, power grid, where do I define power grid? This is where connection, so generating using, okay. So I'm going to tweak this back. Powered is just going to be a visualizing thing. So you can see, and then we're going to have a new component. Drive, this is going to be called, it needs a drive component. It's going to be called grid. Pub struct grid. Okay, and you're going to hold a U16. Right, then we're going to import component view. Component for grid. Right. So the way this is going to work is we're going to say type BevyECS component. That's wrong. BevyECS component storage type is table, and then we're going to go register component hooks. So we need to register an hooks dot on insert new world entity and underscore. Do that. All right, we need to copy this, and we need to do the same as on replace. On replace. Okay. Now you're not going to do anything at the moment. The power grid is going to be fn connect itself and grid, which is going to be U16. Okay. Then we're going to say next, and we need empty because we need a vector. So they're the ones that are empty, which is at some point we need to go, yeah, empty. Empty is going to be just a vector. Like that. All right, so when we say connect, we're going to say self dot maybe we should not have next, we should have used. No, okay. We call connect, we say self dot well, first off, if self dot next equals grid, self dot next plus equals 1. This is just going to be to make sure that, like, if you're adding them to the grid after the fact. It'll make sure that next is sort of somewhat likely to not hit something. So when we say new empty, we'll rework this. So to do. Okay. So next we're going to say grids dot entry, and we're going to say grid or insert power grid default. Okay. And then is it dot connections plus equals 1? Okay. Apparently power grid doesn't have default. Can I derive default on you? So, okay. So basically we go, hey, if there's already a power grid, increment. Okay. So then we need to have an fn disconnect. Disconnect. Okay, so disconnect again takes in mute, self, and grid. Okay. Then we just need to do the same thing, is self.grid to entry. We don't need or insert, so it's more like if sum grid equals get mute key. Okay. First off, you okay. If let some grid power grid. Okay. Here is grid. So we do that. Then we say grid dot connections minus equals 1. Now we should debug assert that grid dot connections is greater than 0, because you shouldn't be able to disconnect from a grid when there's nothing connected, because like you should only be calling this when something's actually connected to the grid. But we only want to be debug assert because we don't want the game to crash if somehow you end up in an invalid state. It's just a check. Anyway, and then if grid dot connections dot equals 0, then self dot empty dot push grid dot connections. No, just grid. Push the grid onto the empty list. Because we called it grid. Okay. So we should probably call this grid ID then. Okay. And then we push grid ID. Like so. Why? Oh, because it's a mutual reference. So if grid connections is now equal to 0, then self dot push the grid to the empty list. Okay. So when we say if grid dot empty, if self dot empty dot can we say self dot empty dot remove damn, okay, if self dot empty dot contains grid self dot empty dot find Okay, this is going to need to be a hash set, simply because I can't be bothered. Self, and it's going to be lazy, like self.empty remove grid. We'll remove it even if it's never there. Okay, and then grids, then we insert. Okay. And then we insert instead of pushing. Okay, so now when we say next grid, can we say empty dot pop? Oh, okay, so instead we're going to make this a index set instead of a hash set. And then we're going to say next empty. We're going to say if some grid equals self dot empty dot pop grid. If that's some, okay, else dot swap group. Okay. So then we're gonna say here we can grid and we go otherwise while self dot power grids dot contains key self dot next self dot next plus equals one. Probably the worst way of doing that, but then we're going to return return self dot next. Technically I should probably call self dot next plus equals 1. So then when we start at 0. Okay, then we say index set. Okay. No. Okay. Give you a reference. All right. That seems a bit silly. So when we say next empty, we either pop the first one off the empty list or we keep incrementing next until it's empty. It should, in theory, find it the first time every time because we should always be looking for that should be up to date, but it's not always up to date. So, right. Then down here we say, okay, so instead of looking for powered, you're actually looking for grid. Like that. Okay, and then you say next empty, and then you insert grid. Okay, so this is the fast iterer, and so technically these don't go grid. This is powered. You get grid. Okay. Nice. And then you're the same. You're actually supposed to be grid. Like so, and then you say grid. Grid equals that. Okay. So then we go back up to here and we go, when I'm doing this, we want to say grid equals world dot get entity grid dot expect just inserted. We need to dot 0. And we have the same thing for you. Okay, and then we need to go world dot resource mute, and that resource is power grids dot connect to grid, and then again copy this, go down here, and we're going to call disconnect, and then You're actually not just inserted, you're just replaced. Okay. So when we add a grid, we connect to the grid. When we leave the grid, we disconnect from the grid. So if we just spawn and despawn entities, that should keep our power grid. Let me guess. You have a fast way of doing this. Or default. Where would you look at that? Or default. Connection +1. Cool. So that means that whenever we enter the uset powered, like so. I think, okay. Then apply panel. So we're still working on this. So to apply our panel, we do this, and then we say commands dot I guess if grid does not equal 0, well, that's the question, isn't it? Like, if grid does not, maybe expected semicolon. Okay, so if grid does not equal 0, commands dot entity okay. Well, first off, you're just the one that added the solar panel, so there's no point doing a weird double lookup. So your entity is somewhere up here. So your grid, oh no, your entity added grid entity dot insert grid. I guess technically we don't even need to check this if 0. We can just say that your grid is 0. Now, the thing with that is we need to we need like different components. Like we need a component this is where I'm really running into the weeds of I don't know how Bevy works in terms of when the required components are. So generating no, that's the size. Struct consuming using no, not static struct using derive component required That grid doesn't have default. That is interesting, isn't it? Like that's going to cause issues because we're going to be disconnecting from 0 all the time. So we need to go to our power grid and say, when I say disconnect, if grid ID equals 0, return. Same with if grid ID equals 0, just return. Because we don't care if there's no power grid connected. Like if you're trying to change this. If it's trying to connect to disconnect from grid 0, it's like it's not connected. Like 0 is our marking, which is not the best way of doing it. Really, it should be like an option. But anyway, using and consuming. They should really not be editable. Generating. Okay, so down here, when we add a grid, we say if gain equals if let world dot get generating dot map g.0 unwrap or now or default. Yeah. Do that one, but for consuming. Using, because I can't spell. And then we say, hey, when we get a power grid, call connect. So let grid equal. So when I call connect, can you actually return a mutable reference? To the power grid. So I want you to say like grid equal this, and then say grid.connection plus equals 1, and then return grid, please, so that I can do other stuff with it. That's no, terrible way of doing it. I feel like you just need to return an option. It's just so bad though. Because at that point I may as well say you can't pass in 0 because I know that it's going to return none. And otherwise it's going to return some. So I'm just really telling you if you passed in 0 or not. I mean, the lazy thing to do is then implement power grid. Just import option power grid. And then just say FD. Oh, see, I can't do that. I can't implement impulse for foreign type. That would have been funny. It's just to say like, you can just call whatever you like on it. Like just call the function. If it's none, it'll just ignore it. Anyway, what were we doing? We were working out down here and saying, hey, if let sum grid equals this, else continue. Oops. Else return. You think? I think that's right. All right, and then we just say grid dot add gain, and then grid dot use making. Okay. Free gain, free. Remake. Okay. Same logic again. We need to go these. Okay, we just take all of that, don't we? Grid.disconnect. Disconnect. So that means disconnecting also needs to return a fucking option. Ugh. So you do the same thing. Say else you return. Wait, no, this is thumb grid. Otherwise, you return none because you're saying that the grid is empty now. There's no need to clean it up, and then we also need to say here that if we grid dot generating equals 0 and grid dot connections dot using equals 0. Okay. What is your problem? Oh, because I put a square bracket there somehow. How did I pull that off? That's a real fucking head turn, that one. Okay, head scratcher. That's the word. Anyway, so now we need to go to power grid and we need to implement power grid. Import power grid. Gain. Oh, make. Which takes in itself and a
size. You don't return anything. You say self make self dot generating plus equals power. Use. Alright, let's say about using. Lose. So I call it lose. Self and power. Which is self dot generate. Okay. Using plus equals power. FM sub self and power. If self dot generating is greater than power, self dot generating minus equals power, else self dot generating equals 0, and sub lose self power if self dot using is greater than power, self dot using minus equals power. Well, yeah, I figured the stream got boring. I've got distracted actually writing proper code. Okay, so self using generating using equals 0. Technically, this introduces some issues. Apparently I'm passing it at U32. Why am I using it at U32? Why not a U size? There we go. Okay. So then we come down here and we go, hey, when you call power grid temporary value dropped. Okay. So this should be more like if let some grid do this, give it else. And then you're the same of if let some grid make plus. Okay, so that should, in theory, make power grids kind of work. So you insert the grid, you're going to go here, 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 and you're going to say generating. And you're generating, how many solar panels were there? It was 7. So when we call apply panels, we're going to say, hey, you're generating 7 power. Apply poll. Now, I don't remember where I was spawning in the textures for the, like, when do I actually spawn the power pole? Probably in the map editor, somewhere in here is probably where I'm generating the power pole. Yeah, and then I pass in this handle and that handle. Okay, so all I need to do is go up here and say, hey, so we need data as a local data. It's going to be object data. Okay, so we need to struct object data. And just derive default. All right, and then you're going to be a local object data. Okay, so active is a boolean, and then last, which is a ID, and then object. It's just going to be usize because I can't be bothered making any num at this point. Next, we would need to go
input, which is res e button input key code. Okay, we're getting there. We're almost at the point where we can test this again. So if input just pressed key code digit 1, then data dot object equals 0, else if input just pressed key code digit 2 data dot object equals 1. Then we come down here and we go hello, yes you so handle is going to be if data dot object equals 0. Now I'm really writing sloppy code. Else okay, so you will need solar, and then down here when we say enter, we need to do the same thing. If data dot object equals 0, else connections dot entity dot insert solar panel. Paste that in, cut that, put it here, power pole here, solar panel. That I'm going to ignore that because that's technically not correct because of what I'm doing, but anyway, we don't need these two. Okay. So I have no way of checking to know if the code's actually working. But we'll have an interesting look at to see if we can spawn in. Oh, the water is all pink. Oh, that's interesting. Why is the water all pink? Because I changed the name. Don't mind that. That's because in here. Water. No, that's objects. Terrain. Every time you see the word water. Case sensitive. Do I have objects? What do I do? So if you see space, you need to find everywhere that it uses this exact phrase, and we need to replace it with blue. Okay. Do you have an extra space in you there? Okay. Place all 22 instances with blue, save, reload. Hey, there we go. Okay. So next we want to go, if I press 2, and we come over here, and we go, hey, can we, oh, nope, non-triangle meshes are not allowed. I have forgot to triangulate my meshes. Tab A, Control T, file, export, OBJs, export. Should really just work out how to triangulate meshes in code and get it to not throw an error on that, but anyway. Bank's also the wrong name, but anyway, that can be fixed later. It just doesn't look nearly as... Okay. That's very much wrong, because you're just always placing those poles. Why are you not registering the correct thing? So map editor, why is this not working? Object equals 1. I am setting it to 1, yes. If I press digit 0, if I press digit 2, so I press 2, You should be placing solar panels, but you're not. Interesting. Huh. I also find it interesting that I must have not renamed dirt to brown. Okay, so digit to digit. Why is this not working? Did I not save it? Something or other? So, okay, so that's just not working. The somewhere where am I? What am I doing wrong? So power pole solar panel handle power pole, but unknown UV type bank. Yep. Okay, so you could be having an issue with that one. Found power pole. So we should probably go fix the UVs for one. It's not bank, it's brown. You only use grey, but it could be that it's not loading the material. Not STL. File, export. Can I get you to print me real quick something like print line set 0 set 1. I'm not sure why it's not working. It doesn't make sense to me. Okay, yeah, we set 1. When I click, hey, didn't exactly work how I was expecting it to work. Why did you spawn a fucking 2 sets of solar panels and a power pole? That doesn't make sense. Now you're spawning power poles. So if I click and try, that's why you don't fucking duplicate code. I think it's everything from the last downward. Okay, which means everything from last down to here. And then we go, hey, don't duplicate code, but also like continue duplicating code because I'm lazy. I think I need to return because if you technically move, you spawn. Why did you spawn 2? Anyway. Now, question. Solar panels, if I go F8, shouldn't spawn power. Yep. But you do. Hey. Now the other issue is that I believe you are... Maybe not. Ooh, that's interesting. Unexpected too. I didn't think it would work like that. I must be overriding it when I... How the fuck am I doing this? Huh. To be honest, I don't know how my fucking code's working at this point. Please, someone knows how to use shaders, help. I need a shader that does this instead of doing it in code so it's not so goddamn slow. Alright, so the other thing is I kind of want to like a thing that links up stuff. Oh, that's hilarious. Well, it's not going to show up now because I've overwritten it. There we go. It should work. Yeah, you can see it spawning in at 0 and then being moved 1 frame later. So that's what that is. That blinking one is because they're spawning in and then moving after the fact. Yeah. They also have no materials. It's fine. Hmm. Kind of cute. Maybe I should be using UVs. I think the issue I would find with UVs is that like each vertex uses its own. Like the UVs are saved separately, which really blows up the number of vertex UV pairs that there are. Hmm. Alright, anyway, that's somewhat working. Now I want it, like, you can put in a power grid. There's no way of knowing if it's actually working in terms of, like, whether they're connecting to each other. But, I think I gotta work on some boring stuff offline where I can think more. And I'm gonna call that a stream for today, so hope you all enjoyed. Had a reasonable number of people popping in and out. And I'll see you in the next one. Hopefully, I'll have a video done where I go into like the mesh generation and stuff, and how Bevy is too fast sometimes. Yeah, thanks for tuning in.